Hey everybody, it's me, Armando Diaz. Today, we'll be talking about angles and angle relationships. This was also made by Giovanni Gomez, Joseph Martinez, and Christian Pornega. But it was mostly me. Alright. Here's the basic vocabulary about angles and angle relationships. You should already know this, but I'm gonna say just in case. An angle is the space between two intersecting lines of surface at or close to the point where they meet. A right angle is an angle of 90 degrees. An acute angle is an angle smaller than 90 degrees. An obtuse angle is an angle larger than 90 but smaller than 180 degrees. Okay, here are the basics. Alright, just a quick side note. This did not line up perfectly, so it's obviously not going to show the right angle, obviously. So, yeah, don't mind that. But if it did line up, then it would show 72 because protractors are good and useful. But if you don't have a protractor, and it's a straight line like this, then what you should do, obviously, is add this up and then subtract it from 180, because 180 is a straight line. Okay. Okay, here's the main vocabulary. Complementary angles are either two angles whose sum is 9 degrees. Supplementary angles is either of two angles whose sum is 180 degrees. An adjacent angle are two angles that have a common vertex and a common side. A vertical angle is each of the pairs of opposite angles made by two intersecting lines. A transversal is an angle passing through parallel lines. A bisector is the division of something into two equal or congruent parts, which congruent means equal. These are the vocabulary that you will be using most of the time. Okay, so these are examples of angle relationships, which we will be using later on in this problem. Okay, so first comes the linear pair. 5 and 6, the angles 5 and 6, form 180, which is linear. And yeah, that's pretty much it. Okay, let's read this. Angles 5 and angle 6 are adjacent angles whose non-common sides are opposite rays. The angles form a linear pair. Linear, linear, linear. Remember that, just remember that. Okay. Adjacent angles, right here, it says angle SRT and TRU have a common vertex and a common side, but no common interior points. They are adjacent angles. Okay, so what this means is just you have a common vertex and a common side, which you could see here, RT, RT. Yeah, it's pretty simple. You should understand that. Okay, let's move on to vertical angles. With vertical angles, I just like to take the opposite of an angle. So if they ask you to find a vertical pair, it's probably the opposite. In this case, it's this. And these two over here are also vertical angles, but they just don't show that here. And if you are asked to draw the angles, you should draw a little line right here to represent that these two are vertical and these two are vertical and that they're different and stuff. Okay, here are the examples. First, let's find an angle adjacent to BGD. So it needs a common vertex and a common side. We have this, which is DGC. We also have EGF. GB. We also have uh, AGD, or AG. Wait, sorry, my bad. That was not a G. GB. So there's probably like 3 more in there. So there are a bunch of adjacent angles in this one. Name a vertical angle to EGA. EGA. So, like this one, it's basically this. So it's just the opposites, cause this is that. So we gotta find that. So I'm just gonna say DGB. No, my bad. Keep on doing that today. Okay. Name an angle that forms a linear pair with DGF. Let's draw DGF. So DGF. Okay, boom. We could do EGF. Yeah. Then also DGC or AGF. Wait, will EGF work? I think so. Yeah. So we have CGD. We also have AGF and E. Oh, that looks like an F, kinda. My bad. GF are all linear pairs. Okay. Okay, let's delete this. Boom, 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 boom. And now with the last question in this little example, is name an angle vertical to FGB. Another easy one. Vertical angles are super easy. FGB. So that's this angle right here. So we're just going to take the opposite and do that. So it seems like C, G, E. So E, G, C, or CGE, however you want to say it, on a little line of it. Or actually, you just gotta put that thing. Okay, there you go. Now we're done with this example, this whole big example over here. Now we can move on to this. Okay. Oh, this is fairly simple. All we have to do is, okay. If Ariana turns the stove dial 135 degrees to the right, what setting will the dial be in? Or on, sorry, my bad. I got these from Khan Academy, by the way, if you want to check more of this out. Okay, so we know that half of 90 is 45, and 90, which is right here, low, plus 45 is going to be 135, and half of 90 is 35. Sorry, and half of 90 is 45. So it's going to come out to be med low. So B is your answer. Okay, now that we're done with this and spent a bunch of time with this, we now move on to the next one. Okay, I made this slide for fun, but it's actually kind of serious. Not really though. Angles used in the real world. Okay. I put this in the PowerPoint because I just want to show you how important angles are. If you plan on becoming any of these, or being in any of these subjects when you grow up and work in these fields, you're gonna need angles. So lots of angles. Thankfully, you're cool. Okay. So some of the jobs or subjects, however you want to call them, that involve angles is one, engineering. Also,
Machinist.
Yeah, machinist, what Google said. Angles are needed for welding, also for soldering, also for brazing workers, also for electricians, architecture. So my point is that you need them for a lot of things, and so you should listen to your geometry teacher, my bad, so you could be successful. Yeah. Alright. See y'all later.